Hello everyone, I hope you are all well. Thank you for being here at LRAC. I will be presenting my team's paper, Simple Additions, Substantial Gains, Expanding Scripts, Languages, and Lineage Coverage in URIEL+. This work was done with collaborators from Ontario Tech University, the University of Toronto, University of Michigan, and Ghent University. The core idea of this work is simple. Our small, targeted additions to URIEL+ can lead to substantial gains in multilingual coverage and performance. I'll start with a brief introduction to why language similarity matters in multilingual NLP. Then I'll walk through our three main contributions, which aim to reduce different types of sparsity in URIEL+. After that, I'll show how we validate these changes, both in terms of imputation quality and downstream tasks. And finally, I'll conclude with key takeaways and some directions for future work. URIEL is a knowledge base that represents languages as vectors, capturing typological, geographical, and phylogenetic features. One of its key strengths is that it allows us to compute distances between languages based on these features. URIEL+, our previous work, builds on this by adding more data sources and improved imputation methods, soft impute, KNN, leading to better performance on downstream tasks. To make this more concrete, consider the example on the slide. If we ask whether Spanish is closer to Italian or Japanese, URIEL or URIEL+ can quantify this directly. As we see, Spanish has a lower distance score to Italian than Italian does to Japanese, meaning Spanish is much closer to Italian than it is to Japanese. This kind of similarity signal is exactly what many multilingual NLP methods rely on. So why does this matter in practice? Suppose we want to train a part of speech tagger for a low resource language. A common approach is to transfer from a high resource language, but the question is, which one? If we choose a language that is more similar, we typically get better performance. URIEL and URIEL+ help us quantify this similarity in a principled way, rather than relying on intuition. And this is especially important when working with low resource or underrepresented languages. Despite its usefulness, URIEL+ still suffers from several types of sparsity. First, it does not include representations of writing systems, features such as whether a language is written left to right, whether a language is an alphabet or abjad, whether a language does or does not have casing, which can affect tokenization and transfer. Second, it has incomplete language coverage, and many languages are simply missing. Third, its lineage-based imputation is limited in scope, only affecting the dialects of 6 medium to high resource languages, meaning genealogical information is underutilized. These gaps motivate the contributions we propose in this work. To address these issues, we introduce three main additions. First, we add script-based features. Second, we expand lineage coverage using Glottolog. And third, we improve lineage-based imputation. The overarching goal here is to reduce sparsity and improve coverage, which in turn better supports multilingual NLP, especially for low-resource languages. The first contribution is adding script vectors. URIEL+ previously had no representation of writing systems, even though scripts can strongly affect NLP performance. For example, scripts influence tokenization, orthography, and even model transferability. We incorporate features from script source, such as script type, case, and litigator use. These features were provided to us by the script source administrator, Martin Raymond, who we thank again for his assistance. In total, we applied these features to over 7,400 languages. This adds an entirely new signal for measuring language similarity. The second contribution is expanding language coverage using Glottolog, a database of the world's languages. URIEL+ originally includes only a subset of the world's languages. We add over 18,000 additional languages and dialects, the overwhelming majority of which are low resource. This significantly broadens the scope of URIEL+, enabling it to support a much wider range of languages. Some examples of previously missing languages that are now present in our version of URIEL+ include Bajika, one of the 100th most spoken languages in the world, Western Armenian, and Sakizaya. The third contribution is expanded lineage imputation. Many languages in URIEL Plus have missing feature values. In fact, most languages in URIEL Plus have missing feature values. Our approach is to leverage genealogical relationships. That is, we propagate features through language families. For example, features from English can be propagated to its dozens of dialects, and similarly for French, Arabic, and thousands of other languages with dialects. This allows us to fill in missing data in a linguistically meaningful way. As a result of this expanded lineage imputation, we see a dramatic increase in language coverage, especially for low-resource languages, where it matters most. In fact, we could see, even in one case, for inventory vectors for low-resource languages, coverage increases by over 19,000 languages, which corresponds to an over 1,000% increase. This highlights how much useful information can be recovered by leveraging genealogical structure like we did. Next, we evaluate the quality of our imputation following our changes. We compare performance before and after applying our lineage-based approach. Across metrics like accuracy, recall, F1, RMSCE, and MAE, we observed consistent improvements. The key takeaway here is that our approach does not simply increase coverage, it also improves the quality of the imputed data, which overall should benefit downstream tasks. We also evaluate the impact of our changes on downstream tasks using LangRank. LangRank is a framework that ranks transfer languages based on URIEL features. In our previous work, URIEL Plus, we validated the changes we made to the URIEL database in that paper using our new URIEL Plus features. We see strong improvements on several tasks, including XNLI, TAXI 1500, and SIB 200. There are some decreases in tasks like machine translation and entity linking, which suggests that the added coverage introduces some trade-offs. However, overall, we achieve comparable or improved performance while significantly increasing feature coverage. To summarize, we introduced 3 key additions to URIEL Plus. First, we added script vectors using features from the ScriptSource online database for over 7,400 languages. Then, we added integration of over 18,000 languages from Glottolog, an online database of the world's languages. Finally, we added a lineage-based imputation method covering over 26,000 languages. Together, these changes reduce sparsity, expand coverage, and improve performance on downstream tasks. The main takeaway is that our relatively simple additions can lead to substantial gains in multilingual NLP resources. Looking ahead, we have several directions for future work. One is to explore more advanced imputation methods that better exploit the tree structure of language phonology. Another is to keep URIEL Plus synchronized with evolving resources like Glottolog and ScriptSource, as currently it's not synchronized with either and would require consistent manual updates. This would ensure that the knowledge base remains up-to-date and relevant. Thank you for your attention. Before closing, I'll briefly highlight a few important considerations. Our work depends on existing resources like Glottolog and ScriptSource, so it inherits any biases or inaccuracies present in those datasets. Additionally, while script and lineage signals are useful, they are not perfect proxies for deeper linguistic similarity, and in some cases may introduce noise. From an ethics perspective, all data used in this work comes from publicly available linguistic resources, and we ensured that access and usage, particularly for ScriptSource, was done with permission and in a responsible manner. We also emphasize transparency by releasing our code and derived resources. Finally, I'd like to acknowledge my co-authors and collaborators on this work, as well as Martin Raymond and the ScriptSource team, Kazir Khan, and Patrick Littell for their support and feedback. I would also like to thank the LRAC chairs and reviewers for making this event possible. If you're interested, please check out the paper and code on the slide. Thank you so much.